hand it over to you.
Might want to wait till the end. I don't know how interesting this is going to be. If I'd have known we had AP students coming today, I might have done something a little bit more Java related. The reason why I chose Pentaho that I'm going to talk about today is it is written in Java, and it also you can also use a Java-like transformation step, and there's also a JavaScript step as well built into it, and we'll talk a little bit about that more later when I get into the steps. Pentaho is a package by the Hitachi group. It's a, I'm talking today just about the data integration portion of it, but it's part of a larger enterprise application to do business analytics for large companies, or you can even use it in your small companies, or for anything you can use. They do use it for business analytics, for reporting, gathering your data from multiple resources, and then being able to transform that data and then display it in a way that either display it in a way that you need to see it as a report situation, or to use it for integrating environments. And I'll talk a little bit about how we're using it, or how we have used it and are using it at Hobby Lobby. So Pinho data integration enables users to ingest, blend, cleanse, and prepare diverse data from a number of sources with visual tools to eliminate coding and complexity. Pentaho puts all data sources and the best quality data at the fingertips of business and IT users. That's just a fancy statement right off their website. Basically, we'll talk more about what it does in general. So Pentaho is, like I said, is a part of an enterprise suite of products, and that you can use for business analytics and for reporting. It's what's called ETL, which is extract, transform, and load data. So extract from one source, transform it, load it into another source. If you think of it kind of as a pipeline, taking data from one place and transforming it and moving to another. It's very well documented. They have a wiki. They have tutorials. They have community forums. Anytime I Google it, I hit a lot of Stack Overflow. I don't know if a lot of people are aware of Stack Overflow, but if you're doing any kind of IT development, it will be your friend for solving a lot of problems. Allows connecting almost any data source or as an input and an output. I'm having trouble reading this, guys, because I really need my reading glasses. I'm old. So, oh, wow, now I can actually read. Okay, it comes with a graphical user interface. So their development paradigm is visual. So it's laying things out using a visual type layout rather than programming. As you kind of see the layout, you'll kind of see how it could be programmed in multiple steps, but these steps are laid out into multiple graphical images, and then you point from one to the next, and we'll start seeing it in here in a minute when I start showing some pictures, and it'll explain that a little bit better. It allows for ease of debug and development, and there's a free community edition of the data integration with an Apache license, so it's very easy to download and use to play around with. So some of the main concepts of Pentaho are transform anything into anything, has a quick preview at any step of the transformation, flexible flows and exception handling, custom transformations logic via Java and JavaScript. So if there's not a step that to do what you need to do, you can quickly write some code to do it for you and just inline that in with the other steps. You don't have to program the whole thing from front to back. You can generate various types of data, so there's a way to be able to just generate random test data if you need it. And jobs, there's another part to it where you create jobs to flow from transformation to transformation, so it allows you to build a whole workflow. And we'll look a little bit at that as well. So here's a picture of the visual design tool. It's called Spoon, and as you see, there's down the left-hand side are your categories of transformations, and you just drag them and drop them, and we'll start looking in the next slide here. You'll kind of see how that works. So this is just a transformation example. In this example, we're reading data from a sales file, looking for any sales information where we're missing a zip code. And if it's missing the zip code, then we're going to do a lookup from a postal codes file, another file that it's reading in. And then it's going to, once it finds that zip code, it's going to put the files together, or put the data together, and then that's going to pass on to to writing out the file with the zip codes. And if it already has a zip code, then that'll just pass straight on through to the right. And in the end, we'll end up with a file with all the zip codes that we're missing filled in. And we're going to build that as a demo a little bit later, so you'll kind of see how that all works. So there are a number of input widgets that you can input data from all different types of sources. So you can import from CSV files, which is known as content separated values, or comma separated values, maybe that's what you've heard, which is data where each field is separated by comma. It can be delimited by any character, and you can choose which character that it's delimited by. You can use fixed width files, which is a file where each field is defined as being a certain length, and so the data all lines up in those, starting at that same column, and so there'll be spaces between data where it's shorter than the actual fixed width. You can read in from email messages. So really good if you want to feed email messages through it, and then do searches for, or pull out certain information from your emails and aggregate that kind of data. Custom data grid, which just allows you to build your own data grid of custom data if you want to write some test data to test your system with. You can generate rows of random data, and you can generate random values. So with random rows of data, it just randomly sticks strings or numbers in there, or in a particular field you can have it build you a generic value, a number, an integer, a string, or whatever. There's a number of data formats that you can input from. XML, JSON, RSS, LDAP, YAML. I don't know if any of you are aware of what some of these type of frameworks are. JSON and stuff are just a way of showing data, but in more of a hierarchical format. And if you're familiar with those, you'll know what I'm talking about. You can input data from database tables, or you can input from streams. Kafka is a development environment that has stream data. Streams themselves is just basically a series of data set up by fields, and so you can pull that data in from a stream. Stream could be from another transformation. Output widgets, you can output a number of different text files, the comma separated files, the fixed width files. You can insert, update, and delete rows in a database, depending on what you've pulled in. You can write out to the number of formats that you can read in from, the XML, JSON. You can write out to properties files, which is just a simple key value file where key is, say, the directory and equals, and then the directory that you want it to go into. So it's just a way of putting a property into a file and then using the properties file to define it for whatever environment you're in. You can also write out a SQL file, which would be all the SQL needed to update or insert rows into a database. There's a number of transform widgets, which are used for transforming your data. You can add constants into your stream of data. You can add a sequence starting with whatever number you want to start it with and incrementing by whatever number you want to increment by. Starting at 1, incrementing by 1, with just every row that comes through would just increment. The first row would get number 1, the second row would get number 2. It can also reset when one of the fields of the current data changes. You can reset your sequence back again. There's a calculator function that can take fields and can either concatenate or add them together or do a number of different calculator functions. You can concatenate fields together, which takes two fields and just puts them, if they're string fields, just concatenates them together and into one field. You can do a replace in string using standard or regular expressions. We'll look at that in a little bit. Select values is used to reduce or rename fields. So what we mean by reducing is that as the flow continues between transformations, you're going to be passing a number of fields to the next transformation. If you have a very large file and you're not using all of the fields from that file, all the data from that file, if you can eliminate some of those fields, that just means less data for it to pass on, means less memory that it has to hold on to, and the faster your transformation will run. You can set field values by changing a field value to another value or set it to a constant value. You can sort rows. You can split fields. So take one field and split it into multiple new fields. And then there's a number of string operations that you can do. Trim, upper, lower, add padding, escaping XML, which means when you escape XML, it changes certain characters within an XML field that are specific to XML itself that has to be escaped to a sequence so it doesn't get confused with an actual tag. There are utility widgets. You can change your file encoding. You can clone a row, so take a row and clone it to make it a new row. You can delaying of rows just allows you to slow processing down by adding a wait value between rows. So there are times when it may take a while for the previous row to be completed, so you want to add a little extra time before you move on to the next, or maybe it's throttling too fast. You want to throttle things down. Things are running too fast. You want to throttle things down so that maybe whatever this is flowing into downstream can keep up with it. You can execute a shell script, execute another process, or you could execute basically another transformation from one transformation to a new transformation. You can write to a log file, which just keeps track of where you're at and what you're doing, and you can also create zip files. There are a number of flow widgets, so you can append streams. So a stream is, like I said, is just a stream of data that's flowing from transformation to transformation. You can have multiple streams flowing in to the append streams, and it will append them all together and then continue them on in one complete stream. In order to do that, you have to have the same number of types and columns to make the streams be able to append. There's a blocking step, which just allows, can somebody get the door full? A blocking step, which can be used to block and wait for everything to finish from one transformation before it moves on to the next transformation. And the reason for that is, and I think I failed to mention this in an earlier slide, is that when we go from transformation to transformation, everything runs in parallel. In other words, it's going to spawn as many threads as it can spawn, and it's going to run things simultaneously. So when it starts processing the first row, it takes that first row, processes it, moves it to the next transformation processes it, and it's going to send it on and just keep on working on it. And each of these steps, regardless of having all the rows completed within this transformation, it may not have completed all of its work upon the rows before it passes it off to the next row. So blocking step you can put in there to say, wait, let's wait till all these rows are processed before we go on to the next step. And then there's a way to do that. There's a dummy step, which just does nothing, which is actually used as a part of the previous step for blocking. You can have everything run into a dummy step, and then you can say wait for that dummy step, which means it's going to wait till all rows reach that dummy step, and then you can continue on your processing from there. You can filter rows using a regular filter. There's a way to build just a regular filter. You can use Java to create a Java filter, which just uses Java code like an if statement to process the data. You can prioritize streams, so you can have a number of streams coming in, and like append streams, a number of streams come in, and you can prioritize prioritize and say which one of those streams do you want it to run first, because maybe you're getting streams in at out of order, and you want to, once again, run them in order so they can flow on to the next step. And then there's switch case, which just it's like an if that has multiple of possibilities that it goes to. So if this, and it'll go off to this step. If it's case of the next one, it'll go off to a second step, a third step. It's different than just your basic if else, which just says if it's true, they go to here, false, go to here. Now it says if it's true, we're going to go this way. If this is true, we're going to go this way. If this is true, we're going to go this way. The number of scripting widgets. You can execute SQL script on a database. You can create Excel, or you can use Excel-like formulas for transforming your data. The modified JavaScript value is where you can perform a kind of limited JavaScript. You can actually write some JavaScript in there. It's not the full JavaScript code. There's a Regex Evaluation. If you're familiar with regexes, you can create expressions, match upon those expressions, and pull out pieces of a field to forward on based upon those matches. You can use a user-defined Java class. It's not a full working Java, but it does allow you to create methods and use the Java syntax to pull your data in and do some transformations that with stuff you may not be able to find in any of the other steps that are available. And you can also use a user-defined Java expression, which all the fields then are exposed as Java types and allows you to access those fields. Like a string field would give you all the methods that are on the string class for a Java class to be able to use. And then there's a number of lookup widgets. You can do database joins and lookups. There's fuzzy match using a number of different logic algorithms for matching fuzzy match. If you're not familiar with what fuzzy match is, that means you're looking for time, the word time, and it might say, well, lime is really close to it because the first letter is slightly different, so it might fuzzy match on lime. Or time could be the same as hour is a part of time. So anyway, there's just different logic algorithms that could do these fuzzy match lookups. You can also do HTTP client calls and get and post calls, basically. You can do REST client calls. You can do a stream lookup, which can take another stream and allow you to look up data from the current stream you're in based upon a field from your stream that's also available in the other stream. It can do a lookup, and then you can pull in fields from that stream into your stream. And then there's also web services lookups. And then there's also the ability to be able to do jobs. And jobs is another type of, it's not so much a transformation as it's a flow control. It has a number of widgets itself for being able to do some checks like whether a file exists. It can pull multiple resources from multiple places and then build them into a stream, and then you can have it pass from one transformation to the next. They all execute sequentially, so unlike executing in parallel, they execute sequentially, so everything has to finish with one step before it moves on to the next step, which you can use then jobs to do your flow control as well by separating your transformations into multiple transformation files and then using a job to do those flow controls, so you don't have to use blocking steps. The output can then be rerouted after a transformation depending upon the result from that transformation, and they can be triggered by an external means, by a shell script or a Java class. There's just an example of what a job might look like. It starts, it checks to see if a file exists. If the file exists, then it's going to go into the transformation and transform the files, and then, or transform that file and then finish. You can declare variables. There are system variables already defined, and you can create your own user variables. In the example there, you see the transformation has a set of properties for the transformation itself, and you can set a variable. In this case, we're setting an input directory or an output directory that can then be used by the step down below where you're doing a text file input and you're looking for a file or directory. You can pass in that parameter, looking for a file in that path. You can define these at transformation level. You can also define those in the job level. And if you define them in the job level, then you can pass those parameters into each transformation. Therefore, the transformation itself doesn't have to know exactly where the path to the file is. That can be determined by the job at the beginning. So they can be referenced in fields and widget properties. And in transformation code itself, you can also access them within like the modified JavaScript step. You could access that variable in that step as well. And in a number of the other steps, there's places where you can use it. And they're accessed by the nomenclature of $, and it's supposed to be curly bracket. If you can't really see that over here in the example, or maybe you can on yours a little bit better, but it's the curly brace, not the parentheses marks. So it's $, curly brace, then the variable name ending with the ending curly brace. The Pentaho also gives you the ability to do data preview and to get metrics. So with previews, any step in the transformation you can right click on and you can do a preview. It will run to that step and then will show you the output that would be passed on from that step to the next transformation. It would show you all the fields and the data that's in those fields. And then you can also add in conditional pause and stop. If you want at that point, you don't have to continue on. And it's nice for just testing out to see if you're where you're at in your transformation and how it's doing without having to save and run for real. And then it also has performance metrics at each of the steps that is kind of showing there in the example. It shows you each of the steps 1 through 4 and how many records were inputted. You kind of see that down here, how many records are inputted, reading in from the input file. This is how many records were output, and here's how many rows of data were read and written from each step. Also gives you the time over here of, and why did I go on to the next? Sorry, I guess I tapped my trackpad there and it went to the next slide. So you can also see that it has keeps the speed of how long it takes to run each of those transformations. And the timing, this was ran real fast. I didn't even have enough to show a time on those. So some of the best practices for working with Pentaho. Steps are executed in parallel. So be sure and leverage jobs or the wait steps to support dependencies that you have from one transformation to another or from one step to another within a transformation. It's good to leverage the Java and the JavaScript steps for complex transformations. If there's one of the other step widgets that you could use, it's probably better to use those. Those have been more tuned than doing straight JavaScript or Java, because those have to be compiled in line before they can be ran. So it does add a little bit of time to your transformation. Always use parameters for input and output sources. I say always. You don't have to, but it's best just it keeps each of your steps from having to know exactly where the file's at on your file system, because if you give the transformation to somebody else to use, they may not have that same file in that same folder. So it'd be nice to then have it with a parameter so that parameter can be changed when they go to run it to point to their folder. And when you run a transformation, and we'll see that in a little bit, you can change those parameters. Every time you run the transformation, it gives you the chance to change those parameters if you need to. It's good to use jobs for grouping multiple transformations sequentially. And so if you have multiple transformations that need to happen at one time, instead of trying to put all those transformations in one huge file, makes it very hard to read, break them up and use a job to sequentially transfer those from one to another. And the best thing I can tell you to do is always keep your input and your output data in separate folders. You don't run a chance of overwriting the file, especially if you're reading a file in and writing it out with the exact same name. You'll find this very helpful. I shot myself in the foot a few times doing this when I read a big file, and the first time I tried to write it, it basically erases the old file if it's there, and you get one row processed, and then it just all kind of breaks, and you're like, what's going on? And you go try to look at the file you're inputting, and there's only one row in it, and you'll figure it out pretty fast, though. All right, so that's kind of it for the presentation portion. So now we're going to do a little demo, and how are we looking on time here? Oh, we got plenty of time. All right, so what we're going to do is we're going to create from scratch a Pentaho integration for this flowchart here. So I know it's kind of hard to read. Sorry. What we're doing is we're reading in sales data, and the sales data is just going to have it's going to have a city, a state, a zip code, and the sales figures for that city. We're going to check to see if the zip code is missing, and if the zip code is missing, then we're going to look up the zip code and then write that out to the file. If it's not missing, then we're just going to simply write it out to the file. Oops, not yet. We're not ready for questions and answers yet. All right, so this is Pentaho, and you'll notice it's called Spoon, and I read a little bit before I came here that all the pieces to Pentaho are parts of the kitchen. So the data integration is called the Spoon, the job section is called Pans. The overall suite is, I think it's called Kitchen, and so these are all bits and pieces of stuff from the kitchen. So transformation of the spoon, I guess, like spooning it out of here and putting it over here. I don't know. That's my guess. When you first start it up, you'll find the welcome screen here. You still see the presentation, don't you? Mm-hmm. Now, that's what I get for. So PowerPoint's nice about letting you have multiple screens, and not so good when you're switching over to using Spoon. Give it a second here. Okay, now is everybody seeing what I'm seeing? Now you're seeing Spoon, or Pentaho data integration. When you first start it up, you have a welcome screen here, and this welcome screen is really nice because it gives you a lot of information if you need it. It has some help on getting started, documentation. There are a ton of samples. There are a bunch of samples that come with Pentaho when you install it. You can go to the forums to look up things if you have questions. Forums, you can ask questions of the people in the forums. There's a mailing list. Jira, if you want to see what bugs are in, or if you want to list a bug, or see what bugs are out there if you're running into something. Continuous integration, if you're the kind that wants to download the latest build of the Pentaho from the Community Edition, and you want the latest to play around with, you can go to their CI builds and pull that down. Lots of blogs, there's books been written, and of course information about how to contact them if you need to contact them. So lots of good stuff there on that start page. So we're going to start a new transformation. So we're going to go to new transformation. We get that screen that I showed you where we have a list of all of the steps, the step groups down the left side, and our work area over on the right. So remember I told you all about these different widgets. There's more than I could actually sit here and talk about today, but there are a lot of different input steps from a number of different resources, and You don't have to use them all, but in fact, at Hobby Lobby, we use a small subset of them. So, but there is a lot there that you can use. So we're reading files in from a comma-separated value file. So let's go look at that. Bear with me a minute. Oops, too far. Presentation. So we're reading in from the sales data. So you see in the sales data here, we have a city, a state, a zip, and sales, and you see that several of those records are missing the zip code. So we're going to read the data in from this file. And then we're also going to read data in from the zip codes file, which has a list of city, state, and zip codes. And yes, I know Dallas and Fort Worth and Oklahoma City have about 100 different zip codes, but I just picked one just for the example for today. So if you don't recognize the zip code and you're from Dallas or whatever, then I'm sorry. All right, so we're going to just click on and drag over the CSV file input, and it's going to put this step here. So we're going to open up the step. We're going to label the step. You don't have to label the step, but it is nice because it just helps you when you go back to read it to see what exactly is it doing. It's reading in the sales data. If you just have CSV file input, you have no idea what it's actually doing under the covers. Okay, now I'm going to back up for 1 second here because I forgot to do my first step. So if I double click anywhere in the blank area, and this is a new transformation, it's going to bring up the transformation properties. Remember what I told you, one of the best practices is to have your own input and output directory. Now in the example, we called it input directory, but I've learned a little something since then. We're going to call this A input directory, and I'll tell you why in a minute, why I'm naming it weirdly. If I could actually spell, I could do it all day long until I'm in front of somebody. All right, so the default value is, and we're going to use the folder, stop it. We're going to use the folder where my data is at, and that is not it. Okay, this is demo folder. So we're going to use the demo folder as my input folder. And then we're going to create an output folder. And we're going to call this output. All right, so now we're going to bring back up this guy. All right, so now in the file name, we're going to do a control space. The reason why I put those A in front of them is because of the way this box works. It allows you to type into this box, but if I were to type in I for input, it would find the capital I of internal, and then if I hit I again, it would go to the next one, and then the next one, and the next one. It doesn't have a way of typing in the full value and doing a search down the list. And it sorts capital letters first and then lowercase letters. So if I had just put in input directory, then I would have had to hit I about 30 times, or I'd have to sit here and hold the arrow key down to get down to the bottom. So by making it A input directory, it scrolled it up to the top, and it made it real easy for me to find. So you can type them in. You don't have to do the control space and the find, but it is kind of nice to have that feature. So now that I've selected the input directory, then I'm going to put in sales data.csv, because that's the file. That's not how you spell CSV. There you go. It's delimited by comma. That's by default for CSV files is comma. You can change that delimiter to anything, and if you want to use a tab, you have to click the little button over here to the side, to insert the tab character in there for you. The enclosure is for quoted data. So if it's a long string that has might have a comma in the string itself, then you would put quotes around it to know that that's all a part of one field and not that comma that's within that is not separating fields. So we have a header row present. So you saw in the data here that there is a header row, city, state, and zip, and in the other file it had city, state, zip, and sales data. So we want to make sure that we have the header row present. So now we don't have to enter all this information in manually. I can click on this Get Fields, and I'll put in 0 to have it read all the fields, and it'll actually read through the fields and try to determine the data type based upon the data that was in the field. It gives you this little summary of what it found and what the field type is and length and everything that it ended up using. And that's just a summary of what it did. So you can click on Close, and then you can see how it filled all this information in for me already. Here's the name it got from that header row, the data, which it tried to interpret from the data that was in the column, and links. So it just used the longest length of any of those columns and made that the length of the field. So since the zip code is not really an integer, it's more of a string field for me, I'm going to choose string as its data type. And because I don't know how big the fields could be, I always go through and delete all the links. Now all that does is just means that it doesn't care how big the field gets. It's not going to truncate your data down as you keep going. If you have no length applied, it just allows the string data or the integer data to grow as long as you need it to. Okay, so after we do that, we click on Preview, and we can just preview the data. So now you see that it's pulling in the city, the state, the zip, and where the zips had no data, it's marked it as a null, and then the sales data. So we're good to go reading that file in. So now we're done. So now we also want to read in the zip code data. So I'll go a little faster on this one, since we've seen most everything already. We're going to change the zip code to string. I wish you could type in that field, but it doesn't allow you to. And then we'll clear out the string links. There's the data. Okay, so now it's reading them both in. So now we want to filter the data from the read sales data, looking for all those where the zip code is missing. So to do that, we're going to do a filter. Now this is really nice to be able to use this search facility up here. So if I want to do a filter, I just type in filter and it'll just change everything over in the left-hand column, finding everything that has the word filter in it. So we're going to filter the rows. So I could do this in one of two ways. I could use filter rows or I could use a Java filter. I'm going to use the filter rows in this case. And then we're going to build our filter. Now this is, it looks kind of straightforward, but yet it's kind of complicated when you get into multiple conditions. So it's going to be real easy to do it for this one condition. So now we're going to, we want to find all rows. So we're going to filter missing zips. All right, we're not going to worry about right now what steps we're going to send the true data to and the false data to, because we're going to do that when we create our hops. So for right now, we'll just leave those blank. The field that we're searching for, okay, once again. All right. So I just said about hops and I haven't created one. So if I hover over this one and hold down the shift key, I can drag an arrow between read sales data and filter zip. And then it's going to ask me, is this your main output step, or is this an error handling step? So you can have every one of these send data to an error handling step as well. So in other words, if it catches some sort of exception, it can send the data out to someplace else other than the main path. So in this case, we're sending the main path. So now that I have that hop created, and those are called hops when you do this from step to step, and it basically shows the flow. So the flow is starting with read sales data. It's going to read in the sales data, and then it's going to flow to the next step, which is filter zips. So you see the arrow pointing that direction. Now when I click on field, I can choose what field from the sales data am I going to build this filter upon. So we're going to use the zip file, or the zip code, because that's what we're actually looking for. And we're checking to see if the zip is null. Okay? So if the zip code is null, then we're going to do something else. But we need to figure out what we're going to do. We're going to do a lookup, right? We want to look it up in the zip codes file. So to do that, we're going to do a stream lookup. So these are both streams, and so we're going to look up one set of data in one stream from another set of data in another stream. Okay? So the data from the read zip codes needs to flow into the stream, main output data. And now, oops. This is why I'd rather use a mouse than this dumb trackpad. So now I'm going to create a hop from the filter missing zips down to the stream lookup. In this case, we're going to use the result is true step, because what we're testing for is any zip that's missing is null. We're going to, that's going to be true. So if the zip is missing, that's the true. So we're going to route the true path down to this stream lookup. Okay? So now let's look at the stream lookup. So from here, we need to first of all check, because there are two paths coming into the stream lookup. We have a path from the filter and we have a path from the read zip codes. Which one of those paths is the lookup, is from the step that we're going to look up from? So we're doing the lookup in the zip codes. So we have a city and a state. We need to find the zip code. So we're going to do the lookup step as the read zip codes. The field we're going to look for, this field, is coming from the path with the missing data. So the read sales data had city, sales, state, and zip, and the zip code is the one that's missing. So that's the path that we're pulling, or doing the lookup. Not doing the lookup from, but doing the lookup with the data. As you play around with this, it'll make more sense. It's hard to kind of explain it sometimes. So we're looking up the city. The lookup field comes from the read zip codes, and we're going to match it to the city there. They don't have to be always named the same, but in this case, they're named the same. We're also going to do a lookup on the state and the state. So basically, this is an ANDed lookup. So it's going to say if the city matches and the state matches, then what do we want to do? We want to retrieve some data from one place. So we want to retrieve the zip field. So the zip field's coming from the read zip code. So that's where I have an actual zip code that matches to that city and state. And then if we don't give it a new name, it's just going to take the name of zip and put _1 on it, because the read sales data also has a zip field. You can't have two fields with the same name. So if we don't name it something, it's going to name it for us. So we'll call it missing zip. All right? So remember, I told you could preview at any step. So let's take a preview of this step right now, and let's see what happens. So from here, we can just do a quick launch and launch it. And we see that we read in city, state. This is the zip coming in from the read sales data where it was null, and the sales data. And the missing zip is the one we just did the lookup on. So Fort Worth, Texas, it pulled in this missing zip code from the zip codes file, and it put it all together in the stream. So now our stream has 5 fields in it that we're going to be passing on. So we've added 1 new field to that stream. All right, and then we're done with that. So now what do we want to do? We want the output to go someplace, right? So let's go back and we're going to do an output step now, and we're going to output it to a text file. Okay. So, in the case of the filter missing zips, if it was missing the zip, we wanted to go do the lookup. If it's not missing the zip, we just want to pass it on straight to the output. So in this case, it's the false path. So if it's not missing the zip, we're going to pass it on to the output. And then we'll go ahead and build this output step before we continue. So this is going to be write out the sales data. Okay, once again, we're going to use the control space, and this time we're going to use the output directory. And it's going to be called sales data. So remember, I called it sales data from the input directory. So if I'd wrote both of those back out to the same directory, I would have ruined this right off the bat, because it would have just wiped out all that sales data. Okay, we don't put an extension on this one because they, for some reason, set up a separate field for putting the extension. Not real sure why, but you have to do that. Under the Content tab, the separator by default is semicolon. We want to change that to comma because we're using comma separated values here. We want to keep the header row as well in the output. And then we're going to define what fields are we going to output. So in this case, we can just do get fields. Now right now, the only path I have coming in here is the sales data that have zip codes. So you notice that you don't see that missing zip field that was added in the other stream lookup because we're not following that path yet. So in this path, we're going to pull in the city, state, zip, and the sales that came from the sales data where we had zip codes. So we're just going to use that. And so if I want to then do a preview at this step, this isn't going to actually write to the file. It's just going to show me what it would have written to the file had we gotten to this step. And you see there's only 3 records. That's because these are the 3 records that actually had zip codes to begin with. So right now we're only seeing those 3 records. And those are what would be written if we were to run this at this point. So now what we want to do is take the output from this stream lookup and we want to write it as well. But it's not going to let us. The reason why it's not going to let us is we're basically appending streams together at this point. And remember back, you probably don't remember back to that step, but when we append streams, we have to have the exact same number of fields and data types. So let's go ahead and delete this path here. We'll talk a little bit about that. So remember when I did the preview on this guy, and let's just run it again so you can see it. When I ran the preview to this step, we have 5 fields: city, state, zip, sales, and missing zip. The other path that was passing in only had 4 fields. It did not have that missing zip file or missing zip column. So what we want to do is we want to reduce this stream down to just the 4 fields that we want to write, and then it'll allow us to bring the 2 streams back together because they have the same fields and same data types. So for that, we're going to use the step. What was that step? I knew I was going to get up here and forget that step. Quit it. All right, maybe the best thing to do is just go back to my select values. See, I knew I couldn't remember it. It's no fun getting old, guys. All right, so we'll just type in select. There it is, select values. It was under transform. So we want to do transform. So remember I said that transform can be used to reduce and rename. So we want the path, once again, to go here. And now from this, I don't have to type in all the fields that I want. I can just do this get fields to select, and it'll automatically fill in all those fields for me because it knows what fields are coming in from the previous transformation. So you see I have 5 fields here. I have a zip and I have a missing zip. So we don't want the zip anymore because that's got all the nulls in it, right? That's the one that we're trying to eliminate. And then I can hold down the control key and hit the up arrow, and it'll move missing zip up to where zip was. But remember I said it's not just data types, but it's the field names as well. So this needs to be zip in order to match with the other one. So I can rename the old missing zip field now to zip because we removed the other zip field. Does that kind of make sense? Maybe? Not really? You'll understand why here in a minute. So now that I've reduced down to the 5 fields, and I can show you that with a preview. This is what's nice about having preview. You can see these previews at every step. So now I have 4 fields again, city, state, zip, and sales, and this has got the filled in zips that we're missing. Now I can bring these 2 back together. So I don't have to use an append streams step. I could, but I don't have to. This because the write sales data can take in multiple input streams and write the data out. So now if I do preview at this step, we see all of the fields. So we have the 3 fields that had the zip code to begin with, and we have the 4 where we had to do the lookup and find it. So we basically filled in that zip file, or the zip codes that were missing. So now that I'm done, I can save the transformation, and I really don't want to save it there. So let's go down here to the talk, the presentation, demo, and we'll call it fix zips. We'll save it, and then we'll run. Now remember I told you at the run configuration you could change the path. So when I do a run, these are the 2 parameters here that I have set up initially, and it allows me to change at this point right now. I can change the value to something else. So if I did all my development working in this Pentaho presentation demo folder, but when I go to run it, if I wanted to point it at another set of files someplace else, I could change the path right here. Since I'm going to use the current path, I don't change it at all, and I just run it. So here you get the logging of everything that happened. Here's my step metrics that you saw earlier that were in the slide. Basically these same steps and how long it took them to run. It took 0 seconds to read in 7 records and 7 zip codes, and it took 0.0 seconds to filter it. Took a little bit longer to do the stream lookup, to select, then took no time for select values or write sales data because basically it's an accumulated time. So really fast when you have small sets of data. I have run this on very large sets of data, and it does, the larger your set of data, it does take more time. It's not super fast, but I've never had anything that's taken, like forever to run, but that's just from personal experience. So now that we have that, let's go look at the output data. So it went in the output folder, and it's called sales data. And so there's the output, same as what we saw in the preview step, but now it's been written back out to a file. So that's just a simple, fairly simple transformation. You can see it takes a whole lot longer to explain it than it does to actually do it. But anyway, that's all I have for demo. So if you guys have any questions about anything we talked about, now's the time to ask them.
What's the license for production? Do you have to have a license for production, or can you run community edition?
It runs off the Apache license, so whatever the Apache's license is on that, we use it in production scenarios, so it,
But you have
but-
what license?
nope, we just use the community edition.
That's it.
We don't, our support is Stack Overflow and their wiki. So, oh, now I can see, I take these glasses off, I can see you all real clearly, but I can't read the screen. Put them on, I could read the screen, but everybody out here was blurry.
You were setting up fields to sort of truncate data. Is that a default setting, or do you want to have it for the
Okay, say it one more time.
When you were setting up like field lengths, did you sort of truncate data longer if you have it for like stuff instead of truncating?
So the question was, when we were setting up the field data, when we were reading in the files, and I told you that the length, it reads the length from the input data and then makes that the default. And I always take the default off because you don't want to truncate the data. Is there a way to just throw an exception on that? Yes, you can, but you're going to have to catch it in a step. So you can catch that with a filter step, and then you can take the filter from that if it's true, and you can write it to an exception file, write it off to another file, or log it, or you could actually have it stop the whole stream if you run into something like that. Right. So the reason why I always leave those off is I don't want to run the chance of anything getting truncated. So it's mainly for strings, the integer. I'm really loud now. I've gotten too close to the integers and the numbers. You're not going to always run into that problem, but the string definitely. So especially if you read in from another file that's got longer strings. So. Any other questions? Miami. Can it do sorting? Yes, you can sort. There's a sort step. So, thank you, Miami. Let's go take a look. That's something we can do here. So let's do something now. So let me pull in sort. So we'll do a sort rows. We'll throw that out here for just a second. And then now I'm going to append the streams. Because I'm not so sure that sort can take multiple inputs. It may, but let's say it doesn't just for now. So now what we want to do is I want to break this. Is it break? Okay. I hate trackpads where you can't tell the difference between the right and the left mouse. Okay. So we'll delete those hops for now. Okay, so now we want to append the streams. So let's append the streams. The result's true in that case. Main output. Oops. Let me see it once. In this case, you can tell it which one's the head hop, which one's the tail hop if you need one file to append before the other. In this case, I don't care, so we'll just leave that blank. Okay, and then we're going to sort the rows. So now we do sort rows. By default, you can change the sort directory that you want because it's going to use a temporary file to do the sorting. And then from here we can say what field are we going to sort on. So let's sort on the sales data. You can tell it whether it's ascending, descending. So let's do descending. So we'll say no to ascending. We don't care about case because it's a number. And anything else there. So that's going to sort it. And then we're going to write it. All right, so Now we just preview at this step. Okay, both head and tail. Oh, so it does force you to. So in that case, you saw where it failed. You can read where it failed, and it put a little minus sign up there next to it saying, hey, this is the step where it happened. So the step basically says that both head and tail step need to be supported. So I didn't put anything in there, so I lied to you when I thought it didn't need it, but it does. So we're going to say that the head hop is the filter and the tail hop is the select values. And now we'll preview it. And this is why you never do live stuff at a demo, unless you practiced it ahead of time. Yep. You're right, we do have an exception up there. Come on. I've already told you how much I hate trackpads. Right sales data is invalid. Thank you. All right. And that's why it's always good to have somebody smarter in the room than you. Oops. Still not liking it. Step right sales data is invalid target. It's telling me oh, filter missing zips. It's way back here. We're getting the problem. Well, if it's way back there, why doesn't it tell me what's wrong back there?
Sir, when you sent it, you set true this way.
Yeah, you're right. So, thank you. So what happened is I tried to redirect the output, but what happened is filter missing zips didn't realize that I had changed the hop. So even though this hop right here is pointing at this append streams, when I open it up, you look and it says send true data to append streams, but send the false data to right sales data. So it mixed them up. So I'm sending true data to stream lookup. So I'm going to go change that back to stream lookup. And I'm going to send the false data to append streams. So it got these things mixed up. So sometimes it makes a mistake. In this case, it didn't know where I wanted to send those outputs. So now that we've changed that, should be able to save. And now let's do our preview. Voila, now we sorted by descending. Thank you. Thank you. So,
Celebrate the small victories.
yes. So thank you, whoever caught that over there.
That was a good catch.
Yeah. All right. Any other questions? He's about to run me off, so I'm thinking,
You keep going, huh?
now we're a little late. We ran a little long. I knew the demo was going to take quite a while to try to explain all that. You guys have any other questions at all? Okay.
If you have any, I want to make sure this trip is as valuable for you as